value of e. Absolute value of e is e. ln of e is 1. ln of absolute value of 1. Absolute value of 1 is 1. ln of 1 is 0. So we get 1 minus 0, 1. 1. It turns out the area between 1 and e underneath the 1 on x function is the number 1. It's unity. 1. Now we need to divide that quantity by b minus a. That's what the front is saying. They write it like this, but it's really just saying divide by the length of the interval.
B minus 1.
B minus 1 is the length of the interval. So I need to take this 1, the result we already got, and divide it by e minus 1. So there's our answer, 1 over e minus 1.
Wait, what is that?
Our final answer.
That looks a lot like, remember exam 3 where you should have gotten something like that from the mean value theorem, but it was equal to a certain number instead of a function?
Usually I'm pretty good at remembering. I don't remember what you're saying.
Me neither.
Which question? On the last test?
Yeah, last.
The mean value theorem of derivatives?
Yeah, it was like 3 equals 1 over e minus 1. It was almost exactly like this, but we had
Happenstance. We are talking about two completely different things here, right? This is the mean value of the function. This is the average value the function takes on from here to here. Right? In other words, oh, the picture's too small. Whatever. So where's e minus 1? Where's e minus 1? Where's 1? 1. So that's 1. That means this is 1. 1.
Trying to see what it's for. It's speed improves distance and calories. So yes.
Alright, so that's the mean value theorem for integral. Do one more.
And so
Yeah.
the length of the interval is 1 over b minus a.
Well, the length of the interval itself is just b minus a.
Okay.
Just e minus 1. And the 1 over b minus a is really just trying to say, take your area that you just found and divide by length of interval.
Wait, what?
Take the area you just found, this area, right?
Yeah.
Which was the number 1. Take that and divide it by length of interval. Divide it by b minus a. That's all it's trying to say. I mean, they could have written it like this. They just don't. They could have said a to b f of x dx over b minus a. That's what it's really trying to say.
Okay.
That's the way to understand it. This is just done for notational convenience, so it doesn't look like some big colossal mess. But it's really saying divide by length of interval. What? Rosales, what's e minus 1? Yeah, plug in your calculator. I want to know an approximate. 1 over e minus 1. Give me an approximate.
1.718.
What is it?
1.718.
Right, but now take 1 divided by that.
Oh.
The whole thing there.
0.58.
0.58?
How many decimal percent?
No, that's fine.
Oh, look, this is 5 hours. That's all. And this is 8
So 0.58 is right about in here.
I'm not going to be going for more than 5 hours. I'm going for 1
That was our final answer, right? 0.58. 1 over e minus 1 was our final answer to this problem. So what is the final answer really trying to connote? It's trying to say that if you made this go through here, right, then at a height of 0.58, right, that's the average value the function takes on. So this rectangle that I've just drawn from 1 to e at a height of 0.58, that rectangle there is the exact same area as the green shaded portion. In other words, what's the value that I should make the height of a rectangle so it has the exact same area as the area under the curve? That's what it's trying to say. For that interval. That's what you're finding. geometrically. You're trying to reshape this curvy area, right, into a perfectly rectangular area, right? What height does it have to be is the question you're trying to answer. In this case, that would be 0.58. That's going to make it work out to be the exact same area. Symmetry. Number 14. Let me make sure we do a few more of these. I mentioned it just briefly a minute ago. To make some integrals easier to compute. Symmetry. Using even and odd properties. So let's see here. Number 14. Integral from -1 to 1, 1 minus absolute value x, dx. So one thing you certainly don't know how to do, and that is to take the antiderivative of absolute value. Okay? Nobody has shown you how to do that.
Is it x over the absolute value?
Is it x over the absolute value of x? Did you say that with certainty? If you were at
Number 14 is about symmetry.
yeah, you can say that. Yeah, you can say that. Yeah, don't say that. Why couldn't you say it? You could say that, right? Because if it's -1, it's on the negative side, it would be.
Yeah, that would be x over the absolute value.
Yeah, you could. Yeah. Tend not to do that, though. I'll tell you, even in practice, tend not to do that. So why? Hold on a second. No, hold on a second. Let me say it's antiderivative. Slicker ways to deal with it. Usually people just, we don't have to in this case anyway, but I'm just thinking, how do you deal with absolute value? Practice? Usually don't write x and absolute value of x. Usually don't write
It was
those.
when we were doing that second project class.
Oh, really?
Yeah, I think the absolute value. I have to find the function line. Just get out. X over x. Absolute value of x. Help me out. So that's what
Well, that's the derivative of absolute value.
yeah.
No, I'm saying the other direction.
Antiderivative.
Yeah, antiderivative absolute value. That's what I was saying.
You don't.
But even derivative absolute value, they don't need to write that way.
It says x sigma x. X SNG.
SNG. SNG?
SGN.
SGN? Signum. Yeah.
Is that sigma?
No, signum. It's a sine function, meaning SIGN function. But man, the point is, since you do not know how to take the antiderivative of absolute value of x, then you must be relying on some other feature here to evaluate this. So in this case, it's going to be the symmetry of the problem. So first of all, you got to make sure the interval is symmetric. So it is. -1 to 1 is a symmetric interval about 0. That's what you're looking for. All this symmetry is about 0.